Hi friends, welcome back to my YouTube channel. So today I am going to discuss about Advanced Communication System EC407 Multiple Access from Module 6 Spread Spectrum Multiple Access Techniques and Space Division Multiple Access Technique. So we have already discussed about SSMA in the last section, and we are now discussing the remaining part of SSMA and Space Division Multiple Access Technique. So as we know, there are so many multiple access techniques available: TDMA, FDMA, CDMA, SSMAs, SDMA, etc. So CDMA is one part of SSMA, and that also we have covered in the last section. So now we are going to discuss more about SSMA, other access techniques. So hybrid spread spectrum techniques. So in addition to the frequency hopped and direct sequence, spread spectrum contains certain other hybrid combinations that provide certain advantages. So in hybrid spectrum techniques, the first one is hybrid FDMA or CDMA. That means FCDMA. So the technique that can be used as an alternative to CDMA, direct sequence CDMA techniques, as discussed in the previous section. So figure shows the spectrum of the hybrid screen. So there is a wideband CDMA and spectrum narrowband CDMA. The available wideband spectrum is divided into a number of subspectra with smaller bandwidth. So the available bandwidth is divided into a smaller number of spectra. That with smaller bandwidth. So each of the smaller subchannel becomes a narrowband CDMA system having processing gain lower than the original CDMA system. So this divided, subdivided or subchannels becomes a narrowband CDMA and having a processing gain lower than the original CDMA system. And this hybrid system has an advantage that the required bandwidth need not be contiguous and different users can be allotted different subspectrum bandwidth depending on their requirement. And the capacity of the FDMA by CDMA technique is calculated as the sum of the capacities of the system operating in the subspectra. So the FDMA CDMA technique, the capacity of this system is calculated as the sum of the capacities of the system operating in the subspectra. So the hybrid direct sequence or frequency hopped multiple access, that means DSPHMA. So here the sequence consists of direct sequence modulated signal whose center frequency is made up of hop periodically in a pseudo random fashion. So here we can see that center frequency is made to hop periodically in a pseudo random fashion. So figure shows the frequency spectrum of such signal. And direct sequence frequency hopped system have an advantage that they avoid the near far effect. So the figure shows the burst transmission in this channel and the alternative channel that may use for other burst. So here what the center frequency made to hop periodically in a random fashion, and this will avoid the near far effect. However, frequency hopped CDMA system are not capable or adaptable to the soft handoff process, since it is difficult to synchronize the frequency hopped base station receiver to the multiple hopped signals. So in time division CDMA, so this is another third section for the hybrid spread spectrum sequence, and time division CDMA, TCDMA. So in CDMA, all called TDMA by CDMA system, different spreading codes are assigned to different cells. Within each cells, only one user per cell is allotted a particular time slot. Thus, at any time only one CDMA user is transmitted in each cell, and when the handoff takes place, the spreading code of the user is exchanged to that of the new cell. So in CDMA, using CDMA has an advantage that it avoids near far effect, since only one user transmits at a time within the cell. And the next one is time division frequency hopping, TDFH. And the multiple access technique has an advantage in severe path, multipath, or where severe co-channel interference occurs. The subscriber can hop to a new frequency at that start of a new TDMA frame, thus avoiding a severe fade of erasure event on a particular channel. The technique has been adopted for a GSM standard where the hopping sequence is predefined and the subscriber is allowed to hop only on certain frequencies which are assigned to a cell. The scheme also avoids co-channel interference problem between neighboring cells if two interfering base station transmitters are made to transmit on different frequency at the same time. So time division frequency hopping avoids co-channel interference between the neighboring cells if the interfering base station on the transmitter are transmit to different frequencies at different times. Use of TDFH can increase the capacity of GSM by several fold. So these are all about the SSMA and regarding the hybrid spread spectrum techniques. So we discussed hybrid FDMA by CDMA and then hybrid direct sequence frequency hop multiple access and time division CDMA, and the last one is time division frequency hopping. So we can conclude this by SSMA. So next one is SDMA, space division multiple access technique. And space division multiple access controls the radiated energy for each users in space. So in space it controls the radiated energy from each users, and it can be seen from figure. So this is the figure for SDMA. Try to add this in the answer sheet as well. And in the figure you can see SDMA serves different users by using a spot beam antennas, and these different areas covered by the antenna beams may be served by the same frequency in a TDMA or CDMA system or different frequency in a FDMA system. Sectorized antennas may be thought of as primitive application of SDMA. So sectorized antenna is an example or the application of SDMA. And in future adaptive antennas will likely to be used simultaneously steer energy in the direction of many users at once, and appears to be best suited for TDMA and CDMA base station architecture. And a reverse link present the most difficulty in cellular system for several reasons. First, the base station has complete control over the power of all transmitted signal on the forward link, and however because of this different radio propagation path between each user and base station, the transmitted power from each subscriber unit must be dynamically controlled to prevent any users from driving the interference level for all other users. So these are all about SDMA. And the second thing is that the transmit power is limited by battery consumption by the subscriber unit, and therefore are limits on the degree into which the power may be controlled on the reverse link. If the base station antenna is made to specially filter each desired user so that more energy is detected from each subscriber, then the reverse link for each user is improved and less power is required. Adaptive antennas used at the base station and eventually the subscribers unit promise to mitigate some of these problems on the reverse link. In the limiting case, if infinitesimal bandwidth or beam width and infinitely fast tracking ability, adaptive antenna implement optimal SDMA, thereby providing unique channel that is free from interference of all other users in the cell. With SDMA, all users within the system would be able to communicate at the same time using the same channel. In addition, a perfect adaptive antenna system would be able to track individual multipath components for each users and combine the min and optimal manner to collect all the available signal energy from user. The perfect adaptive antenna system is not feasible since it requires infinitely large antennas. So these are all about SDMA. So SDMA mainly is focused to control the radiated energy from each users in space. So the most primitive application of SDMA is used by sectorized antenna. So these antennas are used to cover the frame frequency from the FDMA or TDMA system. So you can go through these notes and get an idea of that SDMA. And then last one is OFDM. So OFDM is a special class of FDM, frequency division multiple access, in which the carrier or subcarrier are orthogonal in is known as orthogonal frequency division multiplexing, that is OFDM. So in an OFDM system, if the separation between carrier is smaller than the bandwidth of the data in each carrier, there is a different or significant spectral overlap between the neighboring channel, and yet there would be no crosstalk or performance degradation because of the carrier orthogonality conditions. So what is OFDM? So OFDM is if there is a separation between carriers is smaller than the bandwidth of the data in the each carrier, and there will be a significant overlap between the neighboring channels, and this will cause or this will avoid the crosstalk or the performance degradation because of the carrier orthogonality condition. So in data communication and networking, orthogonal frequency division multiplexing (OFDM) is a method of digital data modulation whereby the single stream of data is divided into several separate substream of transmission via multiple channels. OFDM uses the principle of frequency division multiplexing, where the available bandwidth is divided into substreams having separate frequency bands. OFDM has drawn significant research interest into optical communication recently, and OFDM is widely used in wired and wireless communication system because it is resilient to ISI caused by dispersive channels. It has been used for digital audio broadcasting, HDTV, terrestrial broadcasting, and wireless LANs. And working principle of OFDM. So OFDM, as I said, OFDM is specialized in FDM, having the constraint that the substreams in which the main signal is divided are orthogonal. So the divided signal and the mainstream signal is orthogonal in nature, and these orthogonal signals are signals that are perpendicular to each other. A main property of orthogonal signals are they do not interfere with each other. When any signal is modulated by the sender, its sideband spread out either side. A receiver can successfully demodulate the data if it receives the whole signal. In case of FDM, guard bands are inserted into the interference between the signal, resulting in crosstalk does not occur. And however, since orthogonal signals are used in OFDM, no interference occurs between the signal even if their sidebands overlap. So guard bands can be removed, thus saving bandwidth. The criteria that needs to be maintained is that the carrier spacing should be equal to the reciprocal of the symbol period. In order that OFDM work, there should be very accurate synchronization between the communication nodes. In frequency deviation occurs. If frequency deviation occurs in the substream, they will not be orthogonal anymore, due to which interference between the signal will occur. So that is all about today's section. We have discussed SSMA and SDMA and OFDM. So you can refer this notes. So this is the complete, we have completed the section for multiple access. So we will go to the next section in the module 6 in the next video. So hope you like this video. If you like this video, please subscribe my channel, like, share and comment. Thank you. See you in the next video.